Hello everyone, welcome back to my channel. If you have a habit of solving or referring the previous year question paper while reading, then for sure you will find this particular question for around 3 to 4 times out of 5. Such an important question or derivation we are going to deal today. And if you haven't watched our previous video based on integrated rate equation of first and zeroth order, then please do watch it so that you will have a complete understanding of this concept. Now, moving further, let me state the question, the possible ways of the question. Derive an expression of half-life period of zeroth order reaction, or it also may be stated as show that for a zeroth order reaction half-life period is directly proportional to its initial. Please remember, directly proportional to its initial concentration of the reactant. Now we know that for zeroth order reaction the integrated rate equation is stated as K is equal to R naught, that is initial concentration minus R, that is the concentration of the reactant at any time over T. This is the first step of our solution. Now this is the rate constant of zeroth order reaction. See, while solving such frequently asked question, you need to be so sensitive, or you need to state all the terms which you are taking. Why? Because most of the students will solve, or most of the students, those who want to just pass, will be dependent on such questions, and evaluator will not give whole marks. Why? Because this is a frequently asked question, the question which is predictable. So you need to write each and every term. You need to be thorough with your presentation. So your presentation skill matters a lot. Now, so I have taken all the terms. I have defined all the terms here. Please do the same in your question, in your answer sheet. K is nothing but a rate constant, and R naught is nothing but an initial concentration of the reactant. R is nothing but a concentration at any time of the reactant, and T is a time. And as we are going to derive an half-life period, and so for half-life T is nothing but T half. We are considering the time at half-life. Then the reactant concentration R at any time is equal to the reactant concentration at initial, that is initial concentration of the reactant divided by 2. Why? Because we are considering the half-life. Now substituting these two in the equation 1, that is the integrated rate equation, we will get constant is equal to R naught. There is no change in this term. R naught is initial concentration minus half of initial concentration. We substituted the reactant concentration with half of initial reactant concentration over T half. Now on simplifying, K is 2 times R naught minus R naught. I hope everyone know LCM. 2 is nothing but, take 2 this side, minus 2, and 2 will be retained in denominator. 2 times R naught minus R naught, that is initial 2 times initial concentration minus initial concentration over 2 times T half. Now 2 of something minus something is nothing but 1 of something, that is initial concentration R naught over 2 times T half. Now as we need half-life time period, we are taking T to the LHS and bringing that K to the denominator. We will get T half is equal to initial concentration over 2 times the rate constant. Or with the same equation, the resulted equation, we can state that T half is directly proportional to initial concentration and 2K is constant. So we can say that this term is directly dependent. Dependent is nothing but proportional to this term. If this varies, this varies. If this increases, this increases, this decreases, then it will also decrease. This shows that we proved that T half is directly proportional to R naught. Why? Because 2K is constant. As I told you, please mention each and every term. Please show that your presentation it at its best. Please do all the steps in the similar way. If possible, do it in a still a great manner. So we are concluding this derivation as of now.